Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our second PU Computer Science online classes. In today's class, we are going to start new chapter 3, name of the chapter Logic Gates. So in this chapter, we are going to discuss some important gates like our basic gates, AND gate, OR gate, NOT gate, and also some of the derived gates, NAND gate, NOR gate, XOR gate and XNOR gate. So before going to start, whatever the gates are there in our logic gate, now let's first of all I want to tell some of the introduction in our logic gates. So in our logic gate or maybe to construct any type of gates, we need to use some of the Boolean algebra, and we know that the Boolean algebra values are 0 and 1. So first of all, the scientist Shahanaz applied the Boolean algebra. We know the value of the Boolean algebra 0 and 1 in telephone switching circuits in correction of the telephone connection or the telephone switching circuits connection here. But after the good result, that means no any problem for our connection in the telephone circuits here. So after the good result, some engineer realized that such Boolean algebra could be applied to our computer electronics as well. Clear this point? We can use in our computer electronic also to construct some of the gates. So first of all, we know that it's going to start by using telephone switching circuits, but after good result, such Boolean algebra 0 and 1 value could be applied to our computer electronic as well. So why we using such Boolean algebra in our computer electronics? So we can say that in the computer, maybe any kind of Boolean operations. We know that some of the Boolean operations are there, maybe Boolean expression or maybe the reduction of SOP, POS. So all are the Boolean operations. So in computer, these Boolean operations are performed by our logic gate only. So clear this point here. So maybe you want to perform any Boolean operations by using computer. Such Boolean operation we can perform by using gate like our logic gates. Now what's the meaning of the logic gate? So first thing I am going to select the concept elementary logic gate. So in our elementary logic gate, we can say that the logic gate or simply called as the gate. Okay, the logic gate or simply called as the gate are digital circuits. So the digital circuits are also called as the two-state circuits. So what about the two-state circuits, or which one is called as the two-state circuits? Okay, the two-state circuits. So we can say that the two-state circuits are input and the output. So the input and output signals are either low voltage, we know the value of the low voltage, that is, or low voltage denotes the value 0 and or high voltage denotes the value 1. Clear this point? So 0 denotes the value, or we can say that the low voltage denotes the value 0 and high voltage denotes the value 1. So this is called as the digital circuit, or we can say as about our two-state circuits. So the two-state circuits are input and output signals. The input and output signals are either low voltage, that is 0, high voltage, that is called as the 1. So such gate are also calling as the logic circuits. Clear this point? Maybe we can say as the gate, logic gate, or we can say as the logic circuits, everything is the same, and such logic circuit can be understood with Boolean algebra values. The Boolean algebra values are 0 and 1, and sometimes the input is low, sometimes the input is high. Clear? So now we are going to study what about the input high or the input low here. So clear this point here about the elementary logic gates. We know that digital circuit, two-state circuit, the two-state circuits are input, output, and maybe low voltage 0, high voltage 1, and such logic gate also calling as the logic circuits. Clear this point here? Now we are going to study some of the definition of the logic gate. So now our next concept is the definition of the logic gate here. So in our definition of the logic gate, we can say as the gate or the logic gate is simply called as an electronic circuit. Okay, it's simply called as an electronic circuits here, and that operates on one or more input signal. Maybe we are not going to take one input, just only in one gate. The gate name is the NOT gate, and in this gate we are using one input, one output. But maybe some other gates are there: OR gate, AND gate, NAND gate, NOR gate, XOR gate, XNOR gate. So many, all those gates are there. We using more than one input only. Clear this point here? So we can say that is simply called as an electronic circuit which operates on one or more input signals and always produce an output signal. So this is the definition of the logic gate, and this definition is very important because everything going to start from the definition only here. We already know electronic circuit, the logic gate is an electronic circuit operating by using one or more input signals, and what about the value we are going to use in our input signal, always going to produce one output signal. So this is the definition of the logic gate, and we already completed the elementary logic gate. Now let's some of the types of the gate. So such logic gate or logic circuits or gates are classified into two types. Okay, so are going to classified into two types. So the first type is called as the basic gates, and second type is called as the derived gates. So the most important types, first one is the basic gates and second one is called as the derived gates. And again such basic gates are classified into three types. Clear this point here? First I said logic gate classification are going to divide into two types, basic gate and the derived gates. Now I selected the basic gates, and such basic gate are classified into three types. So the types of the basic gates are NOT gate. Such NOT gate also called as the inverter. Okay, the NOT gate also called as the inverter. It's very important question. What's the other name of the NOT gate? So NOT gate only called as the inverter. Second, OR gate, OR gate, and third gate name is called as the AND gate. Now we are going to complete the next thing about inverter, OR gate and NOT gate. But before going to start the explanation, maybe any type of the gate, such we can say in our gate there are two types. We already know basic gates have many types, that is OR gate, AND gate and inverter, that is called as the NOT gate. Now such derived gate are classified into four types. Okay, the derived gate are classified into four types. The types are NOR gate, N-O-R, not OR gate, full form. NAND gate, N-A-N-D, not AND gate. Next, third one, XOR gate, the full form of the XOR gate, exclusive OR gate here. And the last, fourth type we can say as the X NOR gate, that is called as the exclusive NOR gate. So clear this point here. So we can say that basic type, inverter, OR gate and AND gate. Derived gate are classified into 4 types. The types are NOR gate, not OR gate, NAND gate, not AND gate, XOR gate, full form exclusive OR gate, and XNOR, that is called as the full form the exclusive NOR gate. Okay. Now after completing the types of the gates, now we are going to discuss all those gates one by one. So first of all, I am selecting the first gate, that is from the basic gate. The basic gate, first gate or the types of the basic gate, that is inverter, INVERTER, inverter. We know that an inverter is also called as the NOT gate, the other name of the inverter. Now, why it is called as the NOT gate? So, when you are going to look at the truth table, the output is not the same as the input. When the input is 0, output is 1. When input is 1, output is 0. So, because of this reason, the NOT gate is also called as an inverter. Clear this point here? So, we can say that an inverter also called as the NOT gate, other name of the inverter, and it is called as NOT gate because always the input signal is not same as the output signal. Okay. Now, the output sometimes called as the opposite of the input. Clear this point? The output sometimes called the opposite of the, correct no kya? 0 opposite value 1. The 1 opposite value 0. So sometimes called as the opposite of the input, okay, or the complement of the input signal kya. So this is some explanation about our inverter, that is called as the NOT gate. Okay. Now let's, after that I want to say some of the definition of the NOT gate. Now still here whatever I completed from our NOT gate, it is just only applicable for the meaning of the NOT gate, that is called as the inverter. Now I want to tell some of the definition. So in definition we can say that an inverter is a gate, or NOT gate is a gate with only one input signal and one output signal, and the output state is always opposite of the input state. So this is the definition of the our NOT gate. So clear this point here. So like that only we need to write whatever they added, provided in the textbook. No any changes for the definition of the NOT gate or any type of the gate. So the definition of the NOT gate, we can say that an inverter or a NOT gate is a gate here and with only one input signal and one output signal, and the output state is always opposite of the input state here. Now we know the meaning of the inverter as well as the definition of the inverter. Now let's the most important symbol for our NOT gate. Now this is the symbol for the NOT gate. How we are going to draw? So like this we need to draw the symbol of the NOT gate, X complement of the X here. So clear this point here. So we can say that the symbol for the NOT gate here. So this is the symbol X NOT, that is called as the complement of the X, or we can say in simple word as the X bar, and we know that. So this is the truth table, okay, the truth table for the NOT gate here, and we know that here just only one input signal and one output signal here. So the input signal, that is X here, and the output signal sure we need to use, so depend on the symbol. So X complement of the X here. So like that only the input signal X and the output signal complement of X, we know that maybe the input is 0, output is 1. Maybe the input is 1, the output is the 0. Otherwise you can look at the second truth table, the second truth table also going to show the truth table of the NOT gate, but in this truth table just only I converted the low voltage value to the 0 and high voltage value to the 1 here. We know that 0 that is equal to low, 1 is equal to high, 1 is equal to high, 0 is equal to low. So this is also the truth table of the NOT gate. Now we completed each and everything about the NOT gate. So the last touch to our NOT gate, that is called as the inverter. So we can say that a low input produces high output, is it? So a low input signal that is 0 always produces high output, that is 1, and vice versa. When input is 1, it going to produce the output as 0. So just only I said here a low input that is 0 always produces high output, that is equal to 1, and vice versa. And such NOT operation is also symbolized as bar. Clear this point here? Is also symbolized as the bar. So for example, if you are going to write NOT X, clear this point here? If you are writing NOT X, how we are going to symbolize such NOT operation? Such NOT operation is symbolized, we know that, by using the bar symbol, and in case when you are going to write NOT X, it should be written as the complement of the X, or we can say in simple word as the X bar. Clear this point? So this is some explanation about our inverter, that is called as the NOT gate. Clear? Now we are going for our next gate. The next gate name is called as the OR gate. It is also one type of the basic gate. We know that in our basic gate there are 3 types are there. First one is the NOT gate, second type is the OR gate. Now we are in the concept of the OR gate. Now what's the explanation, or what about, or what's the meaning of the OR gate here? We know that in our inverter, one input, one output. But what about in our OR gate? Whether that is equal to our inverter? No. We can say that it is not equal to our inverter. In our OR gate, we can use maybe 2 input but output always 1, and maybe 3 input always output always 1, or maybe the 4 input output always the 1. Clear this point here? So the meaning of the OR gate. So in this meaning, I want to tell the OR gate has 2 or more input signals. 2 or more, but not equal to 1. Maybe 2, 3, 4. So 2 or more input signals, but only 1 output signals. Clear this point here? Maybe 2 or more input signal, but only 1 output signals here. But how it going to produce the input and the output? So here we can say that if 1 or more input signals are 1, okay, if 1 or more, for example in this truth table, this is 1 input signal, this is 1 input signal, and in this example the 2 input signals are 1, okay. So if 1 or more input signals are 1, that is equal to high, the output signal is 1, okay. The output signal is 1. So this is the meaning of the OR gate. Clear the meaning in this case here? So we can say that in our OR gate, if one or more input signals are 1, that is equal to high, the output signal is 1, otherwise the output signal is 0, okay. So we can say thus our OR gate represents the logical addition, okay. The logical addition, when you are going to add the 2 input signals, and this is the result of the output signal. 0 plus 0 value is the 0, 0 plus 1 the value is 1, 1 plus 0 the value is 1, and always should remember it, when you are going to add 1 plus 1 the value is always 1, don't go to write 2. In Boolean algebra, maybe you have to write the value, you have to take the value 0 or 1, it depends on the gate. Clear this point here? So 1 plus 1, always the result is, output is 1 only here. So this is the meaning of the OR gate. Now we are going to select the next thing, that is the definition of the OR gate here. So in our definition, we can say that we already know, we already started the meaning. So like the meaning only, I am going to start the definition of the OR gate. So the OR gate has 2 or more input signal. So in this truth table, you can see the 2 input signal, and in this truth table, we can say as the 3 input signal, but always it's producing 1 output signal only. Okay. So here 2, in this case x and y going to represent as the 2 input signal, and x, y, z going to represent as the 3 input signal. So OR gate has 2 or more input signals in this case here, and but always going to produce only 1 output signal. And if any of the input signal is 1, if any of the input signal is 1, the output signal is 1. So we can say it represents logical addition, okay, representing the logical addition. And lastly, we can say that no matter how many inputs are there, maybe sometime 2 inputs we are going to take, sometime 3 inputs, and sometime 4 inputs. So how many inputs are there in our OR gate? But here we can say that the action of OR gate is always the same. Maybe for 2 input, always going to use the condition. The condition is the logical addition. Maybe 3 input, the logical addition going to represent the logical addition only. Maybe 4, always we are going to use the logical addition representation only here. Okay. So this is some information about the definition of the OR gate. Okay. After completing the definition of the OR gate, now we are going to go for our next thing, that is the truth table for 2 input OR gate. I want to construct the truth table for 2 input OR gate. The 2 inputs are there, but output is 1 only. So for our input, I am going to use the column name X and the column name Y. Okay, kya? For first column X, second column is the Y. Now whatever here showing, so such one is called as the output of the OR gate here. So such output we can write by using the heading as the F is equal to X plus Y. Okay, F is equal to X plus Y here. Otherwise simply you can use F. F is also called as the output of the OR gate. Okay, the output of the 2 input, 3 input, 4 input of the, but we are in the concept of truth table for 2 input OR gate. So 2 inputs are there, then sure how many rows we need? 2 input, 2 to the power of 2, that is equal to 4 rows. Okay. So the 4 rows, and we know that the rows going to start, that is from 0 to 3. So 0, 1, 2, 3. So in first column 2, 0, 2, 1. In second column 0, 1, 0, 1. And by using all this value, okay, the 2 inputs, all this value I am going to write the output or the result of the 2 input OR gate. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, and 1 plus 1. The result is 1 only. Clear this point here? So this is about our 2 input OR gate. Now our 3 input OR gate here. So in case of our 3 input OR gate, for input the heading, for the input heading I am going to use as the X, Y, Z. Otherwise you can write A, B, C, no any effect. Okay, no problem. So any variable name we can use. So just in this example I am using the variable name as the X, Y, Z. And we know that 3 variables are there. That means 2 to the power of 3, that is equal to 8 rows. So in case of the 8 rows, we can say that how many zeros we need for the first column? 4, 0, 4, 1. Second column 2, 0, 2, 1, 2, 0, 2, 1. We already completed in our last chapter about the 4 variable, 3 variable and 2 variables. And for the last column 0, 1, 0, 1, 0, 1, 0, 1. Like that we are going to complete. And I already said the OR gate represent logical addition. So when you are going to add the first row values 0 plus 0 plus 0, always the result is 0. 0 plus 0 plus 1, the result is 1. 0 plus 1, answer is 1. 1 plus 0, answer is 1 only. So this is the result. And 0, 1 plus 1, don't say it is a 2. I already said in Boolean algebra, maybe the value is 0 or 1. So should remember it, 1 plus 1 when you are going to add in Boolean algebra. So the value is 1 only. Clear this point here? The value is 1 only. Clear this one? And later next one is about our 1 plus 0 plus 0. When you are going to add 1, 1, 0, 1, the value is 1. 1 plus 1 plus 0, the value is 1. And 1 plus 1, always the value is 1 only. Or maybe 4 variable or truth table for 4 input OR gate. That means in first column 8081, in second column 4041, in third column our 2021, in last column 0101, and always the result is 1 only. Clear this point here? Just accept to the first value. Clear? Okay. Now we know that the truth table for 2 input OR gate and also the truth table for 3 input OR gate here. And after completing, now let's the next thing about the symbol for the OR gate. So the symbol are very important. Whatever the symbols are there in this chapter, all those symbols are very important. Okay. So now the symbol for the OR gate. So the first symbol, we can say that this symbol is applicable for the 2 input OR gate. Okay kya? So the 2 lines are there. So the value variable name A and B, and this is the result. So the 2 input OR gate. The second symbol shows the 3 input OR gate. So any variable you can use A, B, C, and finally going to show the result in maybe A plus B plus C. Okay, A plus B plus C. Otherwise simple words you can write as the result also, no problem. Now here one more symbol is there, and this symbol shows about our 4 variable OR gate. Okay, the 4 variable input OR gate here. So 1, 2, 3, 4. Okay, A, B, C, D. So the result, it going to show the result. So the result is the A plus B plus C plus D. Otherwise simple words, that is called as the result here. So clear this point here. We know that why, because in our OR gate the 2 or more input signals are there, but always going to produce only one output signal. And later words we know the definition of the OR gate also, and about the truth table for the 2 input OR gate, truth table for the 3 input OR gate, and all are called as the symbol for the OR gate. And the last touch to the OR gate explanation, that is the OR operation is symbolized as plus. Clear this point? Did you remember how I completed in our truth table? So X first input, Y second input, but while going to display the output I completed F is equal to X plus Y, X plus Y. So the OR gate is symbolized as plus. That is, if you are going to write A or B, okay, if you are writing A or B can be written as the A plus B. Clear this point? So this is about our OR gate. So this symbol is very important. So we can say that the OR gate is symbolized as the plus, and when you are going to write maybe A or B or X or Y. So A or B is there, means you are going to write or taking the result as the A plus B. Maybe if you are using X or Y, then result will get in the X plus Y. Clear this point? So this is some explanation about the OR gate. After completing the basic gate, some types like NOT gate, that is called as the inverter, OR gate, and now we are in the concept of third gate. So the basic gate, third type, that is called as the AND gate. So before going to say some of the definition of the AND gate, now let's the meaning of the AND gate. AND gate can also have 2 or more input signals. Here also not like our NOT gate, 1 and 1 input, 1 output signal. The AND gate like our OR gate, so can also have two or more input signals but only one output signal. So when you are going to look at the truth table, here two input signals are there, one output. And in this truth table, three input signals, only one output signal. So just I started from the same thing only. Can also have two or more input signals but only one output signal, or always gives single output, we can say. Okay. Now this is about the AND gate. Now let's how the AND gate going to produce the input as well as the output, or what's the output we will get as a result. Okay. Now the AND gate, we know that representing the logical multiplication. So here we can say that if any input is 0, the output is always 0. Clear this point here? If any input is 0, the output is always 0. To obtain output as 1, maybe I want to get the output as 1. How I am going to get such output as 1? That means all input must be 1. Clear this point here? So we can say that maybe in any input the value is 0, the result is always 0. If any input is 0, the output is 0. And to obtain, to produce the output as 1, that means we should use all the input must be 1. So thus it going to represent the logical multiplication. Clear the meaning of the AND gate? Okay. Now let's the definition of the AND gate. There is no any changes. Whatever is there in meaning, the same thing I am going to repeat, but also we can need to say the definition of the AND gate. So this AND gate also can have two or more input signals but only one output signal. Correct, no? And when all the input signals are 1, the output signal is 1, otherwise the output signal is 0. So we can say that it representing logical multiplication. So the logical multiplication, when you are going to use the output 0 into 0 multiplication, value result 0. 0 into 1, when you are going to multiply the value 0 with 1, always the result is 0. There is no any doubt, maybe it's a larger number or any kind of number. 1 into 0, always the result is 0. But when you are going to multiply 1 into 1, the result is 1 only. So we can say that our AND gate representing the logical multiplication. Okay. Now after knowing the definition, now we are going to select the next thing, that is truth table for 2 input AND gate. We know that 2 input, that means totally 3 columns we need. 2 columns for the input, 1 column for the output. So the first column name X, second column name Y, and third column name that is called as the output of the AND gate. 2 input output of the AND gate here. So F is equal to X dot Y. We know that the AND operation is symbolized as dot. Okay, the AND operation is symbolized as the dot. So we can write as maybe the F, that is equal to result only. Otherwise you can take as the F is equal to X dot Y. Okay, the F is equal to X dot Y, but we are not going to take the dot. Okay, we are not to read as the dot, it going to read as X and Y. Okay, but the symbol is just only the dot. Remember it, this one. Okay, now this one is about our truth table for 2 input AND gate. Now let's our next thing about our the 3 input AND gate. Okay, the truth table for 3 input AND gate. So first column X, second column Y, third column Z. So all are called as the input. So for the input, the variable name I am using in this truth table X, Y, Z, and last column is called as the output. So the output is the F is equal to X and Y and Z. Okay, so F, otherwise simply you can use as the F. So F is equal to X and Y and Z, and we know that whatever, if any input is 0, the output is 0. Okay, when you are going to look at the truth table, Everywhere the value 0 is there. So when you are going to multiply any value with the 0, always the result will get in 0 only, and to get to obtain the result in 1, that means all the input be 1. So this is our logical multiplication of 3 input AND gate. Now lastly we can say that the symbol for the AND gate, the symbol is very important. So in this symbol we are going to write, so A and B F, that is called as the A and B. Clear this point here? A and B, otherwise we can write as the result. There is no any problem. Okay. So this symbol applicable for the 2 input AND gate. Next symbol applicable for the 3 input or 3 input AND gate, A and B and C. So F, that is called as the result. So we can write for the result as the R, otherwise F, otherwise we can say as the A and B and C. Okay. So like that also we can write, but simply we are using as the F only for the result here. And later next one, 4 input AND gate. So the 4 input AND gate, A and B and C and D, that is equal to the result. Clear this point here? So this is all called as the symbol for the AND gate. And the lastly we can say that the AND operation is symbolized as dot. The AND operation is symbolized as dot here. That is, if you are going to write A and B, okay, the A and B, so such can be written as A and B. So this is the result here. Or maybe if you are using maybe here A and B and C, so it's going to write as the A and B and later next one is the C. When you are using, so like that it is going to write here. So this is the some explanation about our AND gate. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.